Hello and welcome to Math Zone African Motives. Today, we're diving into a powerful method for solving systems of linear equations. Our main goal in this video is to teach you how to solve simultaneous equations for two unknowns using a technique called Crammers' rule. By the end of this lesson, you will be able to apply Crammers' rule to find the values of x and y in any given system of two linear equations. Crammers' rule is a formula that uses determinants. In 1750, a Swiss mathematician named Gabriel Cramer published this elegant method, and it's been a cornerstone of linear algebra ever since. The rule states that for a system of equations, x is equal to the determinant delta sub x divided by the determinant delta sub 0, and y is equal to the determinant delta sub e divided by the determinant delta sub 0. Here, delta sub 0 is the determinant of the coefficients, and delta sub x and delta sub y are special determinants we create to find our variables. An important thing to note is that this rule only works when the number of variables equals the number of equations. For example, two equations with two variables. Before we jump into an example, let's understand the process step by step. This is crucial for applying Crammers' rule correctly. First, the most critical step is to arrange your equations into standard form. That means all your x terms must be in a vertical line, followed by your y terms, an equal sign, and finally, all the constant numbers on the right-hand side. Second, you find what's called the determinant of the coefficients, or delta sub 0. To do this, you ignore the constants on the right side and set up a 2x2 determinant using only the coefficients of x and y from your standard form equations. Third, you find the determinant of x, or delta sub x. For this, you take the determinant you just created, delta sub 0, and replace the entire first column, which represents the x coefficients, with the constant terms from the right side of your standard form equations. Fourth, you find the determinant of y, or delta sub y. This time, you go back to your original delta sub 0 determinant and replace the second column, which represents the y coefficients, with the constant terms. Finally, in step 5, you apply Crammers' rule using the determinants you've calculated. To find x, you divide delta sub x by delta sub 0. And to find y, you divide delta sub y by delta sub 0. This process guarantees that you find the unique solution for x and y. So, to recap, prepare the equations, find delta 0, find delta x, find delta y, and then solve. Now let's put this into practice with a step-by-step example. We will use Crammers' rule to solve for x and y given the equations you see on the screen. Remember, the first step is to rearrange these equations into standard form. Let's start with the first equation, 3x equals negative 4y plus 13. To get it in standard form, we need all the variables on the left side. So we'll add 4y to both sides. This gives us the first equation in standard form. 3x plus 4y equals 13. Now for the second equation, negative 1 minus 5y equals negative 2x. Here we need to move the x term to the left and the constant to the right. Let's add 2x to both sides and add 1 to both sides. This rearranges into 2x minus 5y equals 1. Now notice that our x's are in a column and our y's are in a column. This is the correct setup for Crammers' rule. With our equations in standard form, we can now move to step 2, finding the determinant of the coefficients. Our standard form equations are 3x plus 4y equals 13, and 2x minus 5y equals 1. This determinant, delta sub 0, is formed by taking the coefficients of x and y from our standard form equations. The first column will be the x coefficients, 3 and 2. The second column will be the y coefficients, 4 and negative 5. Remember the formula for a 2x2 determinant. You multiply the elements on the main diagonal and subtract the product of the elements on the anti-diagonal. So we calculate 3 times negative 5 minus 2 times 4. This gives us negative 15 minus 8, which equals negative 23. So delta sub 0 is negative 23. Next, we will find the determinants we need to solve for our variables. Let's start with step 3, finding the determinant of x, or delta sub x. We'll use our delta 0 determinant, but we replace the x coefficient column with the column of constants. Our column of constants is 13 and 1, so our new determinant is 13, 4, 1, negative 5. Let's calculate this determinant. 13 times negative 5 minus 1 times 4. This gives us negative 65 minus 4, which equals negative 69. So delta sub x is negative 69. Now for step 4, finding the determinant of y delta sub y. Again, we start with delta 0, but this time we replace the y coefficient column with the column of constants, 13 and 1. Our new determinant is 3, 13, 2, 1. Calculating this, we have 3 times 1 minus 2 times 13. This is 3 minus 2, 6, which equals negative 23, so delta sub y is negative 23. We've done all the hard work. We have our 3 determinants. Now for the final step, applying Crammers' rule. Let's recap our values. Delta sub 0 is negative 23, delta sub x is negative 69, and delta sub y is negative 23. We just need to plug these into our formulas. To find x, we calculate delta sub x divided by delta sub 0. That's negative 69 divided by negative 23. A negative divided by a negative is a positive, and 69 divided by 23 is 3. So x equals 3. To find we calculate delta sub y divided by delta sub 0. That's negative 23 divided by negative 23. This simplifies to 1, so we equals 1. And there you have it. The solution to the system of equations is x equals 3 and y equals 1. By following the 5 steps of Crammers' rule, we systematically found the answer. We have now met our learning objective for this scene. Now, let's explore a very interesting and important property. What happens if we rearrange the variables in our original equations? Notice that the system of equations is the same as before, but the terms are swapped. Instead of 3x plus 4y, we have 4y plus 3x. This is perfectly valid, as addition is commutative. Let's see if our answer changes. First, we need the standard form for this arrangement. We'll align the y terms first, then the x terms. So we have 4y plus 3x equals 13, and negative 5y plus 2x equals 1. This seems like a minor change, but it will impact our determinants. It's a great way to understand what determinants represent. Because our standard form equations are different, our determinants will also be different. Let's calculate them. Our equations in standard form with y first are 4y plus 3x equals 13 and 5e plus 2x of 1. First, the determinant of coefficients, delta sub 0. This is formed from the y and then x coefficients. The first column is now 4 and 5. The second column is 3 and 2. Calculating this determinant, 4 times 2 minus 5 times 3 equals 8 plus 15, which gives 23. This is positive 23, the negative of our previous result. Now for delta sub x. Remember, in this case, x is the second variable. We replace the second column of our new delta sub 0 with the constants 13 and 1. So we have 4, 13, 5, 1. Calculating this, 4 times 1 minus 5 times 13 equals 4 plus 65, which is 69. Again, this is the negative of our previous delta x. Finally, delta sub y. In this setup, y is the first variable. We replace the first column of delta sub 0 with the constants 13 and 1. So we have 13, 3, 1, 2. Calculating this, 13 times 2 minus 1 times 3 equals 26 minus 3, which is 23. And once again, this is the negative of our previous delta y. So we have new determinant values. Let's see what happens when we apply Crammers' rule to these. Here are our new determinants. Delta sub 0 is 23, delta sub x is 9, and delta sub y is 23. We calculate x by dividing delta sub x by delta sub 0. This is 69 divided by 23, which equals 3. This is the exact same x value as before. Next, we calculate e by dividing delta sub e by delta sub 0. This is 23 divided by 23, which equals 1. This is the exact same y value as before. This leads us to a very important conclusion. When the columns are interchanged, the signs of the determinants change. We saw delta 0 go from 23 to 23, delta x from 69 to 69, and delta y from 23 to 23. They all flip signs. But the final answers for x and y remain exactly the same. This is because the sign flip in the numerator and denominator cancels out. The system of equations itself hasn't changed, only the way we wrote it down. This demonstrates the consistency and power of Crammers' rule. Let's quickly compare our answers with the memo. For example 1.8, the memo shows x equals 3 and y equal 1. Our calculations led to the same result, so the memo is correct here. Now let's look at the memo for example 1.9. The memo has a slight typo. It asks you to solve for y and x, but calculates x first and then y. This is a common practice, but it's important to remember what each variable represents. We followed the prompt to solve for y first, which was 1, and then x, which was 3. The values it reaches, x equals 3 and y equals 1, are consistent with our findings. So, despite a minor presentation discrepancy, the memo's final numerical answers are correct and verify our work. To quickly recap what we've learned today, we've explored Crammers' rule. We saw that it's a powerful tool to solve systems of linear equations. It's a 5-step process. You first arrange the equations into standard form, then you calculate the 3 determinants, delta sub 0, delta sub x, and delta sub y, and finally, you apply the rule to find the values of your variables. We also saw how interchanging variable columns can affect the determinants, but crucially, it does not change the final answer. This reinforces the principle that Crammers' rule provides a unique solution regardless of how the problem is presented, as long as the underlying system of equations is the same. By mastering these steps, you can confidently solve 2-variable linear systems using determinants. I hope this tutorial was helpful. Don't forget to subscribe to Math Zone African Motives for more tutorials to boost your understanding. Thanks for watching.